A ball is released from hot air balloon which is already moving upward, as you see this arrow, with some initial velocity which is in fact 10 meter per second. Okay, and right now, when at a height of 75 meters from the ground, the balloon was rising at this speed and the ball was just released, means it was not intentionally thrown, it was released, but ball was already in motion, right? Why? Because it is in the inertial frame of reference, so it is already in motion and its speed is equal to the speed of balloon. So when you will throw the ball, when you will release the ball, what will be the motion of the ball? It will not go straight down, okay? Rather, due to inertia, because inertia is a property of a matter that always try to continue its state of motion. So if the balloon was moving up, the ball will also move vertically upward on the basis of its inertia, and then it will fall down like this. So what is the speed of the ball at this point is 10 meter per second. And the ball will reach the maximum height where it will stop for a moment, and then it will fall down, and at this point its speed will be once again 10, but its velocity will be negative 10 meter per second. Okay, overall this motion is free fall motion, and you know very well that it's a constantly accelerated motion in which acceleration is equal to negative. For MCQ we can take negative 10 meter per second square. Okay. Okay, students, if I show you the velocity time graph, although it's not required, but it gives us more better understanding, then this graph should be a straight line like this. Okay, because acceleration is constant and its initial velocity is positive 10 meter per second that we will use in equation. And at this point its velocity is 0 when it will reach the maximum height, and this is a time when it will hit the ground and it will have some maximum negative value of velocity. Okay, so in this question what we have to find out, at what time does the ball reach the ground? So of course Chauvet equations we can apply them, okay, because condition is satisfied. So which equation should we apply? We have to find, we are given the displacement 75 meter when the ball was released. So let's apply this equation. S is equals to ut plus half at square. So what is the displacement? Now this is important point. The ball was released from this point, and let's say the ball hit the ground at this point. So it doesn't matter how far or how above the ball has traveled, okay? The thing that matters is what is the distance between initial point and final point, that is 75 meter. So overall, can I say the ball has traveled 75 meters downward? And you know that this is a vector quantity, so it has traveled 75 meters downward, so I must use negative 75. It's not a distance, it is displacement. Okay, with how much velocity it was released? 10 meter per second. Time t is unknown, plus 1 over 2. Acceleration due to gravity is negative 10, and t square. So you will see we will get a quadratic equation that we have to solve. We can take the 5t square on the other side, it will become positive, and then negative 10t minus 75 is equals to 0. You can eliminate 5 by dividing 5 on both sides, so we will get t square minus 2t minus 15 is equals to 0. And here we can say if I multiply 3 and 5, okay, so 5t plus 3t. Okay, so I'm doing factorization for which I need pair, and if you take the t factor out from this, so t minus 5 plus 3 into t minus 5 is equal to 0. Okay, so we have now, we will get two values for the time. Let's see what are those two values. So the one value is 5 seconds when you will put t minus 5 is equal to 0, and the other value is t is equals to negative 3 seconds, which is not physically possible. So what is a time that t is equal to 5 seconds in which the ball will return to the ground? So that's why this is the right answer.